Okay, welcome back for part two. If you guys need to put that on the back of your little half sheet or jot it down, you're welcome to. Okay, last one we got to talk about are these cotangents. Now remember, a cotangent and tangent don't share the same quadrants. So here's our cotangent pictures. Yesterday we talked about tangents being defined here and defined down there as well. Cotangents are different. Okay, we use a different set of 5 points to graph them. So we're going to use different quadrants when we're doing their inverses. The cotangent shifted by half a pi. So on a tangent, these are your asymptotes. The values was 0. Cotangent decreases. We talked about the tangent graphs increasing, if you guys will remember from last chapter. Now, to make this guy 1 to 1, we're going to go from here to here. So we're going to go 0 to pi. So an inverse cotangent, we're going to go 0 to pi. Okay, off of the picture, kind of repeating the same process you guys have looked at. Okay, domain and range switch, all that stuff. And we get to this last little bit here. Okay, we used to go from 0 to pi on the x, so that becomes our range. We used to have a range of negative infinity to infinity, so that becomes our domain. And all of that comes right from the picture. Okay, same idea as we did tangent before. If you're going to use your calculator here to evaluate any of these new 3 that we looked at, okay, we don't have an inverse secant button or an inverse cosecant button. You have to change them into one of the original 3 that we know. Okay, so convert them into an inverse trig function whose range is the same as the one to be evaluated. Okay, so it's just kind of the book's fancy way of saying you don't have an inverse cotangent button, so don't try and do it. Okay, so all this says down here is basically our little chart of what's defined where and where. So we can take the original stuff that we had. We said there's an inverse sine, there's an inverse cosine, there's an inverse tangent. We took an inverse cosine over here to get one negative. We took an inverse sine down here to get a negative sine. Tangent we said we had to remember. Okay. Now, of course, all of these guys are going to be defined in here because quadrant 1 is nice because everything's positive. The cotangent was not the same as the tangent. Cotangent shares something with cosine. So if you want to somehow remember that both of these guys share a c over here, that'd be a great way. Okay. Now we're going to use this to do inverses that our calculator won't let us do. Okay. So here's 2 examples to finish up. Use your calculator to approximate the following. Now we can do these by hand. Okay. Not everything you can. If you want to check them in your calculator, you're welcome to. Inverse secant of 2. Okay, so let's just do part A here. So the question it's asking you is where is the secant 2? Okay, again, I'm not good with secants, but it's the same question as where is the cosine 1/2? Okay, that's going to be something we're going to be able to understand a little bit better. Right? So, inverse cosines defined here and defined here. I guess before we do that, we should go back and fill in the 2 that we missed on our table here. So if we got a cosecant down here, well, it's going to be the same place as the sine down here. Okay. Cotangent, we said, comes over here. Cosine, well, also there should be a inverse secant over here. Okay, so that's where all those guys are, all 12 of them. Now we can go back and finish this problem. Okay, so where is the cosine 1/2? Okay, and that's what all this work is showing you there too. So cosine is 1/2. We got a choice between quadrants 1 and 2. If it's positive, it's got to be in quadrant 1. 1, 2. This guy's got to be a square root of 3. Okay, if you're across from your square root of 3, that means that guy is 60 degrees, which is pi over 3. So I changed a secant problem into a cosine problem to get the same answer. So you guys have actually done that problem before. Okay, if you do that in your calculator, it'll come out as the same thing, but again, you do not have this function in your calculator, so don't try and do it. You have to ask it inverse cosine of 1/2. Okay, you do not have that button. Okay, let's look at this next one here. Inverse cotangent of -3. Okay, now this one's going to be a little bit tougher. Okay, here's kind of all the steps for it. Again, I'll talk you guys through it, but the book's nice enough to print these things up online for us, so we want to make sure we use them. So if I look at an inverse cotangent of a -3, okay, I'm not going to try and go grab the tangent here. Okay, that may help us, but tangent and cotangents don't share those same quadrants. Inverse cotangent we talked about is here and here. We said cotangents go with the cosines, okay, based on the picture, all of that. It's negative, so it's definitely got to be in quadrant 3. Here's some theta. So if the cotangent is -3, that means you have an adjacent over adjacent over opposite, and then we do our Pythagorean theorem here to get square root of 10. Okay. Now, we don't have an inverse cotangent button in our calculator, so we have to grab something that we do. We don't want to use we don't want to use a sine, we don't want to use a tangent. We want to use something that shares its quadrant. So we want to use a cosine here. So based off this picture, your cosine -3 over square root of 10. We know that. All we got to do now, go to your calculator, punch that guy in. Here's the radians. 3.14 is the same thing as pi radians. So this guy's 2.8. So it's coming all the way around in here. It's another way you can check your answers. If you want to convert it to degrees so it makes a little bit more sense to you, I'm going to guess it's somewhere around 150, 140 degrees or whatnot. Okay, if we want to check that again, second cosine -3 over square root of 10. There's your 2.89. If you want to put it in degrees, 161. Okay, so almost 162 degrees with that. Okay, so remember, think about what buttons your calculator actually has: inverse sine, cosine, tangent. Find things that share similar quadrants. Okay, and we'll keep exploring these properties tomorrow.